All right, team, so this is the video for Safety 2 homework requirement number 4, right? So this is the Mike 825 Willie P smoke problem. So let's just jump right in. I'm gonna be needing a couple different things here for anytime I see Mike 825. I'm needing my Alfa Romeo 2, right? My baseline Alfa Romeo 2, I have this to account for my non-standard conditions and all my diagram range. Then I have my, mine's a different color than yours, but this is the Firing Table 155 Addendum Alpha Delta 1. So this is both for Mike 825 and for Mike 825 Alpha 1. I'm also gonna need the low angle GST for the Alfa Romeo 2 because I can use this to calculate my sight for Mike 825 Alpha 1. Okay, so looking at the range safety card here. So tactical situation, you're preparing to shoot from firing point 29 for mission readiness exercise, compute pre-occupation safety utilizing the appropriate TFTs. This particular case, it's Alfa Romeo 2 and the addendum. And the following range safety card, utilize the standard square weight for the projectile listed. So what is the standard square weight for Mike 825 Alpha 1? It's in the 795 Phalion projectile, so standard square weight is gonna be 4 square, right? So let's look at our data, get our highlighter, and highlight the important parts. So weapon, M777 Alpha 2, so it already triggers in my brain that I may have a muzzle velocity correction if I'm shooting anything other than charge 1. Type of fire, low angle, super easy. I don't have to calculate a high angle safety T for this problem, awesome. Ammunition, Mike 825. Okay, now this is important to take note because there's a difference between Mike 825 and Mike 825 Alpha 1, right? You're gonna see both in your homeworks and in the safety practical exercise as well on the exam. So you need to take note whether this is 825 or 825 Alpha 1. In this particular case, it's Mike 825. Okay, we need to make sure we take note of that because the data will be different. Okay, Mike 231 Lima charges, Mike 762 electronic time. 762 is electronic time fuse for base ejecting projectiles. Makes sense that this would be the ammunition we have here. So for firing data, left limit 5480, right limit 6100. Let's go ahead and find our azimuth of lay. So that is 5480 plus 6100. 5480 plus 6100 divided by 2 gives us 5790. Remember, we always express azimuth of lay to the nearest 500 mils. Gives correction, nearest 100 mils. So azimuth of lay is equal to 5800. Azimuth of lay for this problem will be 5800. Low angle minimum range is going to be 6,200 meters. Max range is 8,000. Fuse time and high angle min range is 6,400. Okay, min charge 2 Lima, max charge 2 Lima, and then 2 Lima for fuse time and high angle min charge. So 2 Lima with the 777. I'm going to have some sort of muzzle velocity correction. We'll have to look at the AR2 for that here in a bit. So comments, the following altitudes are determined of construction of the range safety diagram on your map. We don't have a dog leg. That's awesome. That's going to make this super easy. So here we go, survey data, firing point 29. Yep, I have my battery altitude of 368.0 already expressed to the whole mil of, the whole meter of 368, right? So let's look at our altitudes using the min-max rule. So my low angle min range is 6,200, min range max altitude of 450. 6,400 is a min range max altitude of 460. And at range 8,000, that's a max range. I use a min altitude of 490. So once we've identified that, we'll go ahead and extract our safety computation worksheet. So mine probably looks a little bit different than yours. This is not just the standard safety computation worksheet. This is one that we made specifically for smoke safety. Up here at the top, it says Willie P2. Willie P2 is Mike 825. Right, because it shows up in a FATES as Willie P2. Not really important right now, but we've just stripped out a lot of the unnecessary information we need, or we don't need for smoke that we do for HE. So, but we still fill it out the exact same way. So let's look here. So location. Let me go ahead and move this out of the way. So let's look here. Location, to do it, firing point 129. This says 29 down here, so that should read firing point 29. So go ahead and square that in, firing point 29. And that is at grid 5109. So looking at the MGRS grid down here, 5109, 3753. Battery altitude of 368, or the firing point altitude of 368 meters. Shooting charge 2 Lima, fuse time, right? That's the only fuse I have. That's the only fuse I can shoot with Mike 825. And azimuth of lay we calculated was 5,800. As soon as we record azimuth of lay there, just pop it down here. Azimuth of lay 5,800. Now let's go ahead and start constructing our basic safety diagram. So always start with the min range line. Let's go ahead and create a min range line. I don't have any dog legs, so I'm just going to go ahead and make my box. And it's just going to be a basic safety box. Just going to be nice and trapezoidal, rhombal. I don't know. I wasn't a geometry major. Okay. Then I'm gonna have a min time fuse setting. Boom, 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 boom. Okay, so min range we said was 6,200. Max altitude at 6,200 was 450. All right, min time range is 6,400. Then max range of 8,000. Min altitude of 490. Okay, and we have our left limit is 5,480 mils. And I'm gonna have to convert that to deflection. And then right limit is 6,100. Let's go ahead and convert our azimuth to deflection. So from our center line, to get from azimuth of fire 5,800 to azimuth 5,480, how many mils to the left do I need to go? It's 5,800 minus 5,480 gives me left 320. And to get from azimuth 5,800 to azimuth 6,100, my right limit, I have to go right. How many? Let's do 6,100 minus 5,800. Always make sure you work in positive numbers here. If you get a negative number, just rework it. Gotta go right 300 mils. Okay, so switching to deflection, talking in LARs, left add, right subtract. So 3,200 is my common deflection. I need to go left 320, so that's adding 320. So 3,200 plus 320 gives me 3,520 is my deflection on the left. Go ahead and set up my drift equation I know I'm gonna need later. Okay, so, and over here, left add, right subtract, Lars invented deflection, he's an asshole, right? So 3,200 minus 300 gives me a deflection of 2,900 on the right. Go ahead and set up our equation that I'm gonna need for drift here in a bit. Okay. Go ahead and move this to the side. I'm not going to need this for a while. All right, so now that we have this, we can start filling in our admin data down here. So we're shooting charge to Lima, so that's Mike 231. Shell Mike 825, right? Not Mike 825 Alpha 1, regular Mike 825. Fuse time, projectile family. So 825 is still in the Mike 795 family, which means I'm going to use the Alpha Romeo 2 and the addendum, right? So the FT155-ADD-81, okay? Because this is gonna give me my, my table chuck data, just like we do for Illum. So first things first, we need to find if we have a range correction for a muzzle velocity. Because it's in the 795 family, I'm just gonna go to the AR2, refer to my standard Roman numeral page 9. I'm actually just gonna go ahead and highlight that because I use it so much. Roman numeral page 9, and I'm shooting charge 2, which means I have a positive 1 meter per second change, right? Because I'm shooting a 777. And the TFT is based off the Paladin. So I'm gonna add, so for all three diagram ranges. So diagram range 6,200, so this is a min range 6,200. It's going to be charge 2. All right, it's going to apply for all my ranges. Non-standard condition is plus 1 meters per second, and that's going to apply for all ranges. Minus standard condition, which is 0 meters per second. All right, Paladin's the standard. Gives us an increase of 1 meter per second. Applies to everybody, right? And then the range correction will depend upon the diagram range. So let's keep filling these in. So my min time range line is 6,400, and then my max range for the firing point is 8,000. okay? Now I need to find my range correction. So I do this the exact same way as if I was to do it for regular 795. I refer to my Alfa Romeo 2. I'm gonna turn to charge 2, ensuring I'm in the correct charge. I'm gonna go to table Fox, right? So ensuring that I'm low angle, I'm gonna go to diagram range, Start at the lower one, diagram range 6200. So I'm on page 163 of the AR2. So at diagram range 6200, what is my range correction for an increase of muzzle velocity, right? So muzzle velocity, so column 1-1 increase, come down here to 6200, looks like negative 17.8. Let's go and extract our values first, and then we'll just multiply them across, okay? Next one is 6400. 6400 in column 1-1 gives me negative 18.1. And then for diagram range 8000, column 1-1 gives me negative 20.3. Okay, now I'm done with that. I'm just gonna go ahead and put the AR2 to the side. Now let's do our math. So I multiply the delta, or the change in standard, times the range correction. In this case, it's just 1. So I just do 1 times negative 17.8, which is going to be negative 17.8. Always record the raw value you get out of your calculator, right? And then express to the nearest 10 meters, because we always express range to the nearest 10 meters. Okay, so then that's negative 18.1, which expresses to negative 20. And then negative 20.3 meters, which expresses to negative 20 meters. All these are meters. Okay, now that I have this, I can start down here in my computational space. So let's start recording our diagram ranges. So I have min range 6200 plus a range correction of negative 20 meters. It's gonna give me a total range. So that's gonna be 6200 minus 6200 minus 20 gives us 6180 as our total range. 6180. I don't have a GFT setting because this is pre-occupation safety, so it's just going to be range K of 1. It's going to give me entry range of 6180 at charge 2, and charge 2 will apply for all those ranges, okay? Next, let's do our min time range. Min time range of 6400 plus a range correction of negative 20 gives us 6380 as our total range. Multiply times range K of 1.0000 gives us an entry range of 6380. And then finally, let's do our max range of 8000 plus a minus 20 meter range correction gives us 7980 as my total range. Multiplied times 1.0000 gives me entry range of 7980. Okay, so after I'm done with that, I can go ahead and start finding sight. Now, notice what this says. It says diagram range, use Alfa Romeo 2. So everything to the left of the solid black line, I'm going to be using the Alfa Romeo 2, meaning I have a graphical representation of the Alfa Romeo 2 here on my GST, right? So I extract my GST. I'm going to use this to find my sight. I see here that it's Alfa Romeo 2. It says HE Mike 795, but 825 is in the 795 family. So I can use this to calculate my sight for Mike 825 smoke, okay? Make sure I'm on the correct side. So charge 231, and I've got charge 2 Lima right here. So let's go and set this aside and start finding our VI. So our VI at min range 6200, VI is target altitude minus battery altitude. So that's 450 minus 368, which gives us a VI of positive 82, airborne. Okay, positive 82. Before we find our sight, let's just find the other VIs. Do I need a VI for min time range 6400? No, because I don't need quadrant for that. I just need time. I just need my min time fuse setting and my min time range line. Okay, and then my max range, 490, so target altitude of 490 minus battery altitude of 368 gives me a VI of positive 122. That's a pretty big VI, positive 122. All right, so now that I have that, let's go ahead and find our sight. So I'm gonna take a look at my diagram ranges. Everything I have is below 10,000, so I'm just gonna use my regular rules for calculating sight using the GST. So first things first, VI of positive 82. 081 positive 82. Okay, and I'm shooting target above gun because I have a positive VI at 2 Lima, range 6200. So that's 60616 6200. Make sure I have everything lined up correctly here. Okay, so let's go ahead and extract our 3 numbers. So it looks like my 3 numbers are 141. Place the decimal to where the sight is large as possible without surpassing the value of the VI. So that gives me a sight of positive 14. Now let's find sight for max range 8,000. So at max range 8,000, VI of positive 122. It's positive 121, 122. Positive 122, target above gun because of positive VI at 2 Lima, range 8,000. That's 75. Okay, hold on. It's getting kind of close there, so we got to get it kind of close to the eyeball. 75, 76, 77, 78, 79, 80, 8,000. All right, so there we are there, right? And go ahead and extract our 3 numbers. Looks like 175. So 175, make the, place the decimal so the value is as large as possible without surpassing the value of the VI. So that put it at 17.5, which expresses to 18. So positive 18 is my sight. Okay, now that I have that, I'm crossing my solid black line. So what I want you to do on your homework, on your safety PE, and on your exam, as soon as you cross the solid black line on Mike 825, I want you to take your Alfa Romeo 2, and I want you to put it on the ground. Literally just throw it on the ground. Because we don't need the Alfa Romeo 2 for anything beyond the solid black line. What we need is the addendum. We need the addendum, right? Because the addendum is for our Mike 825. This is for our table chuck safety data, okay? So AR2 is on the ground. First things first, we need to find elevation. Okay, so the addendum is broken up into 2 parts. Part 1, right? Part 1 is for projectile smoke Mike 825, regular Mike 825. Part 2, which starts on page 121, is for Mike 825 Alpha 1, okay? Don't worry about the fuse. The fuses are interchangeable. Don't worry about that, right? But part 1 is Mike 825 starting on page 1. And then part 2 is Mike 825 Alpha 1 starting on page 121. So which one do we need to be in? Shell Mike 825, regular Mike 825. So that is part 1, okay? So next I need to go to the appropriate charge. So let's go ahead and look for table chuck and the appropriate charge. Okay, so charge 2 Lima, table chuck starts on page 4.5. I'm just gonna verify one more time up here that I'm using projectile smoke Mike 825, not 825 Alpha 1. All right, so now I need to find elevation at entry range. Because I'm crossing the solid black line, I'm gonna go ahead and put a sticky note to the left of everything of the entry range, right? Because I just need to use entry range to the, for the right of the solid black line. So let's see here. So I need to find entry range 6180 at charge 2. Where are we at? Oh, so okay, so we're here on this side. So I'm on page 4.6 of the addendum. Okay, so let's see here. Is range 6180, is 6180 a listed value? 6180 is not a listed value, okay, which means we're gonna have to do what? We're gonna have to interpolate. So we interpolate in table chuck for safety data for both illume and smoke. So let's go ahead and take out some scratch paper. Okay, so we said elevation at range, I'm here on page 4.6, right, in table chuck, Mike 825, right, charge 2, and we're looking for elevation at entry range 6180. Okay, 6180, I don't know the elevation at that range. 6180 is not a listed value, so what do we have to do? We have to interpolate. So 6180 falls between 6100 and 6200. Okay, and then let's see here. The elevation corresponding with range 6100 is 254.1. And then elevation at 6200 is 259.8. All right, now let's set up our brackets. So what is our little bracket over here on the left? What does it take to get from 6100 to 6180? It takes 80 meters. What does it take to get from 6100 to 6200? It's 100. So that is 80 over 100 equals, little bracket on the right is always X, right? Let's find our big bracket. So that's 259er minus 8, or correction, 259er 0.8 minus 254.1 gives us 5.7. Okay, so 5.7. All right, and now it's time to cross multiply. So 5.7 multiplied times 80 divided by 100 gives us 4.56. X equals 4.56. Always express at the X to the value listed in the column on the right. So 4.56 expresses to 4.6. Now let's add it back in. 254.1 plus 4.6 gives us 258.7. Sanity check, does 258.7 fall between these two values? Yes, it does. So our elevation at range 6180 is 258.7. Let's go ahead and block this off to keep my work neat. Okay, so we said 257. As I extract, I express. So 258.7 expresses to elevation 259. All right, so now quadrant is the summation of elevation and sight. So that's 259 plus 14 gives us 273. Okay, so quadrant 273 is a safety T value, so I'm going to go ahead and circle that. All right, do I need a min time fuse setting at my min range line? No, I don't, right? Because I just need to calculate my quadrant to my min range line. Now I need my drift. So drift at entry range 6180, probably gonna have to interpolate again, right? So drift at range 6180. Okay, I can just use what I have here, the column on the left, right? Because it's gonna be the exact same. So 6100, 6180, 6200. Just go ahead and set up my brackets while I'm here. 80 over 100 equals, right? And I'm trying to find drift at 6180. So drift is in the same table. I don't have to turn any pages. It's right there in column 5, right? So at 6100, it is left 6.0. And at 6200, it is left 6.2. I wonder what my drift is going to end up being. Okay, so we do know that this is just going to be 6, but you know, let's just go ahead and do the work, just get a rep at it. Okay, so little over big equals little over big. So 80 times 0.2 divided by 100 gives us 0.16. 0.16 expressed to the X, so that expresses to 0.2. So 6.0 plus 0.2 gives us 6.2. Does that fall between these two values? Yes, it does. So drift at range 6180 is left 6.2. As I extract, I express to left 6. Before I do that, let's go ahead and keep our work neat. So drift is going to be left 6. All right, so now let's go to entry range 6380. What do I need at entry range 6380? I just need my min time fuse setting because that is, it corresponds with my diagram range of 6400, right? So time at 6380. Okay, so 6380, what is the time? Okay, that's probably not a listed value. No, it's not, so I'm gonna have to interpolate. 6380 falls between 6300 and 6400, right? And then the time fuse setting associated with range 6300. So I'm looking in column 3 here is 19.7. Notice how it says fuse setting for Gray's burst, right? So 19.7 at 6300, and at 6400 it is 20.1. Now let's set up our brackets. So this little bracket over here, what does it take to get from 6300 to 6380? It takes 80 meters over 100. So little over big equals, little bracket on the right is always going to be the X, is always going to be X. 20.1 minus 19.7 gives us our big bracket of 0.4. So little over big equals little over big. Now cross multiply. So 0.4 multiplied times 80 divided by 100 gives us X equals 0.32. Express at the X to the value in the column on the right, which is to the nearest tenth. So that expresses to 0.3. Now let's add that back in. So 19.7 plus 0.3 gives us exactly 20, so 20.0. Sanity check, does that fall between these two values? Yes, it does. So our fuse time at entry range 6380 is 20. This should read 0. Sorry, I was writing a little fast here. 20.0, there we go. Okay, keep our work neat. So 20.0 is already expressed to the appropriate value. 20.0 is a safety T value, so I'm gonna go ahead and circle it, okay? Now, what do I need at max range 7980? Do I need a time fuse setting? No, I don't, but I do need a quadrant and I do need a drift. So I need to find elevation at entry range 7980. Okay, 7980, I need to find elevation at that range. Is it a listed value? Probably not. Let's find out. So one of the ways that the addendum is a little bit different than the AR2 is you'll notice that like the ranges here, they go from 3,500 to 7,000 on page 4.6. And then on page 4.7, it's basically a whole new page. It starts at range 7,000 and goes up to 10,500, right? So I'm gonna be on page 4.7 of my addendum, verifying one more time. I'm M825, charge 2, table chuck. Yep, good to go. 7980 is not a listed value, but it does fall between two listed values, right? It falls between 8,000 on the bottom and 7,900 on the top. All right, let's set up our brackets. So this is 80, this is 100, little over big, oh my goodness. So little bracket over big bracket equals, all right, now we need to find this side. So at 7,900, what is my elevation? Elevation in column 2 reads 367.9, and at range 8,000, it is 375.0. Okay, and then I'll set up my brackets over here. Little bracket on the right is always X. Need to do math to find our big bracket. So that's 375.0 minus 367.9 gives me 7.1 is my big bracket. So little over big equals little over big. Now cross multiply. So that's 7.1 multiplied times 80 divided by 100 gives me 5.68. So X equals 5.68. Express at the X to the value listed in the column on the right. So 5.68 expresses to 5.7. Let's add that bad Larry back in. So that's 367.9 plus 5.7 gives us 373.6. Sanity check, does that value fall between 367.9 and 375.0? Yes, it does. So elevation at range 7980 is 373.6. Elevation at range 7980. Boom, 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 and boom. Okay, so as I extract, I express. So 373.6 expresses to 374 is my elevation here. Okay, quadrant is the summation of elevation and site. So that's site of positive 18 plus 374 gives me quadrant of 392. Safety T values, so I'm gonna circle it. Now I need my drift at my max range. So drift at range, entry range 7980. I can just pull down the equation I set up on the left or the column I set up on the left here. All right, it falls between these two values. Go and set up my brackets. So that's 80 over 100 equals X over trying to find drift at 7980. What is drift at 7900? So drift over there in column 5 at 7900 is left 8.9. And at 8,000, it is left 9.1. I wonder what our drift is going to be. Let's just do the math anyway. So little bracket is always X on the right. Let's find our big bracket. So 9.1 minus 8.9 gives us 0.2. Little over big equals little over big. Cross multiply. 0.2 times 80 divided by 100 gives us X equals 0.16, which expresses to 0.2. Okay. 8.9 plus 0.2 gives us 9.1. Sanity check, does that value fall between these two values? Yes, it does. So drift at range 7980 is left 9.1. You know, y'all probably good at safety by now, right? It's going to be left 9. You know, y'all probably good at safety by now. Go ahead and organize your work like this, right? This way you can go back and see what you did. This way you can rapidly go back and check your answers for the safety exam. Okay, in the event you take an exam where you can test up, you can go back, try to find the arithmetic where you screwed up. If you keep them organized, you'll be able to find it easier, okay? All right, so now that I have both my drifts, let's go ahead and apply them up here to my basic safety diagram. I'm done with the sticky notes, so I don't need this anymore. Let's look here. So starting with my left deflection. So left deflection, which side is open? Which side is going to keep me out of jail? Left side is going to keep me out of jail, so least left. Which side is open for business? Left 6. Yep. So left 6, 3526. So 3526 is our deflection on the left. And then look here at deflection 2900. Which side is open for business? Which side? Right. Right side is open for business. Left side is closed. Right side is open. So least left, most right. So that's left 9. So it gives me 2909 on the right. Okay. So now that I have all of my values, I can go ahead and record them down here in my safety T. So admin data first, location firing point 29, which is at MGRS 5109, 3753 at altitude 368. This is charge 2. Shell Mike 825, not make 825 alpha 1, right? Fuse time, azimuth of lay, we said was 5800. Always start with deflections. I only have 2 deflections. This makes it super easy. Start from left to right, 3526. And the right deflection, 2909er. My deflection should get smaller as I move left to right. Just do a sanity check. Yep, good to go. Okay, now, what is my max quadrant for low angle? Max quadrant is always associated with the max range line for low angle. So diagram range 8000 is my max range line, which is quadrant 3902 up top here. All right, which gives me my min range is my min quadrant, right? Min range line is 6200. So at 6200, quadrant is 273. And then my min time fuse setting for my smoke, let's see here, min time fuse is 20.0. So there you go. That is the homework, what is it, safety 2, homework requirement number, oh man, I already lost it. Where'd it go? Yep, requirement 4. So this is your Mike 825 Willie P2 smoke.